Okay, let's begin our lesson on maxima and minima. Maxima and minima are things you may have seen already, and I know we've seen in our class a couple of chapters ago. We looked at the maximum value and minimum value of a parabola. Um, Now, if we're looking at when we looked at vertex form, if we look at this, we can easily identify the vertex as 2, 4. So let's record that here. The vertex is 2, 4. The maximum value of the graph is y is less than or equal to 4. That is because the vertex is what limits our parabola, or the parabola is limited by the vertex. In this case, the y value of the vertex. There are no values. You'll notice here there is no parabola. So the parabola exists below y equal 4. That's why we say y is less than or equal to 4. And it occurs when x equal 2. So this limitation of the parabola occurs when x is 2. That's basically our vertex. Okay. Does the graph have a minimum? Quite simply, we know the answer is no, because the parabola opens downward. And because it opens downward, we know it has a maximum value. Considering this is vertex form. The vertex we know has a horizontal shift of +3, so we'll be at 3, and it has a vertical shift of 7, so it's gone right 3 and up 7. So if we were drawing this, we'd have to continue this graph. Say it's a 6, 7, and 3, 7 would be right here. And so our parabola would be stretched by a factor of 2. I'm going to erase that line there for now. Be stretched by a factor of 2, and that's where it would be, because we know there's a stretch factor of 2, and that's where that parabola would occur. So the vertex is 3, 7. The minimum value of the graph, in this case, now the graph is limited by the vertex, of course, and the graph is restricted at the vertex, and it only exists above this point, which is y equals 7. So we say the minimum value of the graph occurs above this point. So y is greater than or equal to 7. And it occurs when x equals 3, because that's our vertex. And that minimum value occurs when x is 3. Does the graph have a maximum value? And here we could just quite simply say no. Opens up. We'll say upward. Okay. Again, that should be somewhat of a review. What is an algorithm? Well, and then do you already know an algorithm? Explain. Well, I can probably answer this one first. Some people know what an algorithm is, or you follow an algorithm and you don't even know you are, possibly. In the morning when you get up, you may get out of bed, head to use the facilities first and brush your teeth and then comb your hair and then get dressed, etc. Some people would get dressed first. Maybe they eat their breakfast and then brush their teeth, etc. But everyone has a certain procedure that they follow. Some people have told me in my classes that they heard Sidney Crosby, walks around the entire arena when he walks before getting on the ice, because he doesn't want to walk by the opponent's dressing room. That might be more of a superstitious thing, but for him, it's somewhat of an algorithm. Some people getting on the ice always step with the right skate first or left skate first. Some people tape their hockey stick a certain way before a game, or get dressed in a certain order for a game, something like that. But there are many algorithms in life that we follow. The proper definition is highlighted in yellow here. You'll see that an algorithm is a process or a set of rules to be followed in calculations or problem-solving operations. So in this case, we're going to be following a set of rules to work with our learning goal, which is completing the square. And I'll explain that momentarily. So given y equal x squared plus 6x minus 1, can we identify its vertex? Well, the answer is no. It's not in vertex form, it's in standard form. So we really can't tell what the vertex is. And then this number 2 asks us to rewrite this in vertex form by completing the square. So just to give you an understanding, completing the square is a process for expressing standard form in vertex form. So How do we do that? Well, let me take that question and bring it down here. So I'll have y equal x squared plus 6x minus 1. You'll notice that it's not factorable. We could get root form if we wanted to, and we can find the vertex using root form and finding the midpoint of the roots, etc. But in this case, we also notice a value is 1, and 1 times negative 1, if we multiply a times c, 1 times negative 1 is negative 1. There are no two numbers, only 1 and 1 multiplied to negative 1, and one would have to be positive, one would have to be negative, and this cannot get me a sum of the b value, which in this case is 6. So this is not factorable. And some of you may be looking at c alone, no two numbers that multiply to c and add up to b. So that's not going to work. So what could we do? We are going to follow a pattern. The first step in the algorithm is to ignore the third term. I'll leave it underlined there for a second, but we're ignoring the third term, and we're going to group the first two terms together. We haven't changed the equation or the quadratic, and we literally just group the first two together. And we want to create in brackets a perfect square trinomial, because as we know, we're getting vertex form, and this part of the vertex form is a perfect square trinomial. So we would need x squared plus 6x plus something that has to be a perfect square. And the way we do that is like this. We are going to rewrite this x squared plus 6x, and we are going to take half the value of the b. So I'm going to write here half of b. In this case, that's 3 equal 3. And then we're going to square it. And we're going to add 9 and subtract 9. So follow me here. I have x squared plus 6x. We took half the value of b, which is half of 6, which is 3. And we squared 3. We know it's 9. So we're going to add 9 and subtract 9 in brackets here. So plus 9 minus 9, close our bracket. Let me just move this over a little bit. And we're going to say minus 1. So take a look what we did here again. We took half the value of b, we added it. Sorry, we took half the value of b, squared it, added it, and subtracted it. Again, we technically haven't changed our quadratic because plus 9 minus 9 is really 0. And if that's the case, we still have our standard form, x squared plus 6x minus 1. But what we're going to do now is going to officially create our perfect square trinomials. Because we squared the 3 to get 9, we're going to write x squared plus 6x. We'll keep the plus 9, but we don't need this minus 9. So we're going to put them outside the bracket right there. And then we're simply going to draw a line here. And then we're going to simplify. So to simplify this, well, we know that's a perfect square trinomial, and negative 9 minus 1 is negative 10. And how do I factor a perfect square trinomial? The square root of x squared is x. The square root of positive 9 is 3. And we need it to add up to 6x. If it were expanded, we would add up to 6x. And x plus 3 squared is what we have. And now we can identify the vertex. The vertex is going to be negative 3, negative 10. And we're going to take that. I'm not sure if it'll let me scroll it up here. Can I do that? No. All right, so we'll just rewrite it over here. And we said negative 3, 10, I believe. Negative 3, 10. Does it have a maximum or minimum? What is it, and when does it occur? Sorry, is it negative 3, negative 10? Apologize. Negative 3. Let's write that a little neater. Negative 3, comma, negative 10. In that case, if it's negative 3, negative 10, we'll first look at the a value. And the a value right here is a 1. We don't write the 1, but we know there's an imaginary 1 right there. And it's positive. So therefore, it has not been stretched nor compressed. And we know because the 1 is positive that it's opening upward. So we know a is equal to 1, which means it opens upward. And we know the vertex is negative 3, negative 10. So if it's opening upward and the vertex is negative 3, negative 10, then the parabola is limited by the vertex. So y is greater than or equal to negative 10, and it occurs when x equal negative 3. So to answer this question, so it has a minimum because it opens upward. What is it? The minimum, this is the minimum here. And occurs when x equal negative 3. Okay. And I've got a couple other examples over here that I'd like you to try. So at this point, you should pause the video and then go through this on your own and see if you can follow that same algorithm. And then I'll go through it a little more quickly. So we are going to, again, we want to group the first two terms. X squared plus 8x. And we're going to take half the value of 8, which is 4. We're going to square that, which is 16. We're going to add it and subtract 16. And then we have plus 5. Then we're going to keep our x squared plus 8x plus 16. We don't need the negative 16, so we boot them out and put them over here. And we're going to factor our perfect square trinomial, and that's x plus 4 squared. And then negative 16 plus 5 is negative 11. So the vertex is equal to negative 4, negative 11. And we know that there's a positive 1 value there, so therefore it opens upward. That means it has a minimum. Minimum equal y is greater than or equal to negative 11. And when x equal negative 4. And this one's a little bit more challenging, so hopefully you got a handle of this one. Now we have to group the first two terms. Again, we've done that, but we want to create a perfect square trinomial in the brackets. And in this case, the a value is 2. We want to GCF that. Take the 2 out. I'm going to back this up a little bit. Take the 2 out. We can keep it green, that's fine. 2 times x squared plus 6x plus 11. So all we did is GCF the first two terms. We still haven't changed anything because if we use the distributive property, we know that 2 times x squared is 2x squared and 2 times positive 6x is 12x. And you may be wondering why we did not take the x out. And the reason why we didn't take the x out of here is because we need to have a perfect square trinomial in the brackets. And in that case, we need x to be squared so that we can properly complete the perfect square. So we group the first two terms. We GCF just a numerical coefficient so we can maintain the x squared. And then we'll continue doing what we did before. But beware of what's about to happen here. So we have x squared plus 6x. Half of 6 is 3. And squared is 9, so it's plus 9 minus 9, and then we have our positive 11. And so we're going to write 2x squared plus 6x plus 9, and here you need to be careful. And so I'll do this in red. Because the negative 9 is inside the bracket, everything in the brackets is being multiplied by 2, and this is a very common mistake at this stage of this math. You need to be very conscious of the fact that you have to multiply 2 times negative 9 before you boot them out of the brackets. So in this case, you have a negative 18 plus 11. So beware of that. I kind of call it giving severance pay to this guy. He's being multiplied by 2, give him a severance pay, and then he can kind of walk out. Now you have 2 times x plus 3 squared, and negative 18 plus 11 should get you negative 7. And the vertex, in this case, is negative 3, negative 7. And it is, of course, opening upward, so it's a minimum. And y is greater than or equal to negative 7 when x equal negative 3. Okay, and that's it for today. Hope you understood that. Good luck.